Hello. Hello. Hello, guys. I hope I'm audible. Yes, yes, I can hear you. So let's wait for 2 more minutes. People are still joining in. Yes, Nadeem, you are audible. Yes, guys, I am admitting everyone in one go. So I hope you have all gone through the first session, right? You, everyone has gone through the first session. Do let me know if you have any question from the first session, guys. So in the first session, we were talking about the linear regression. Basically, we talked about the what is machine learning, supervised learning, and unsupervised learning. In supervised learning, we do the prediction, right? So there we took a use case that we wanted to predict the weight of a person basis on the height, right? And then we did the implementation of linear regression in the Excel file, right, guys? Just one second, let me share one file with you. I think one dedicated drive will be created for you guys, right? Especially for the machine learning, right? But for time being, I am sharing this file from a temporary folder in a drive. Okay, so let's. Yes, I'm speaking, guys. I So here is the link. So if you remember, so last day we were discussing about that what is the actual. We came across SSE, which is sum of squared error, then MSE, which is mean sum of squared error, then N is the okay, and we have so for any question. You can say yes, no in the chat box. Guys, a sincere request that if you can be interactive, that will be really helpful for everyone. And we saw one more thing that let's say that we can draw the multiple lines and number of lines, then which line is the most appropriate line? So we call it the least square error, right? We call it this algorithm as a OLS also, ordinary least square. So for a line where we get the least sum of squared value, that line will be my best fit line. Here, guys, any question on this? Now let's move to the. There's no question. Now let's move to day 2. So today we are going to discuss a few more concepts. So guys, I have shared one file with you, with everyone. I hope you have that file access. Please confirm. So this is the file. Basically, this is the file wine.csv. And let me read this file. Import pandas as PD. And after that, I am going to read this file. And now again, it's time for you guys. Spend some time and tell me that what do you see in the data? That what is the insight? The data is very simple, but still, you please check it. Wine.csv. I'll just show this. I will just show you the snapshot. df.head. Yes. So everybody, please get the data set and analyze it. It won't take much time. Very simple, very small data set. Please analyze it. And guys, one more thing, right? I am not monitoring any chat on the WhatsApp. So be on the YouTube and the Google Meet, right? Check it and respond to proceed. So please help me, please help yourself and try to respond. Yes, yes, you are audible. Yes, you are audible. Yeah, that I will explain. So these are just the feature. So what you need to do is you need to analyze it, that what the shape and other things. A very quick, right? A very quick insights, right? And after that, everything I'm going to explain. So fine. So we have a data set here, right? This call as a wine.csv. The file name is wine.csv. And actually, the wine is very famous in the Western countries, especially in the Italy and Germany. Yeah, sorry, Italy and France. And they used to have a wine tester job to find out the quality of a wine and then fix the price of wine. Right. So, do you see any problem with this business model? Definitely, we do have. One is the person dependent, right? Second is that now because it's a person dependent, a person may have the mood swings, may have the party last night, the test bud may not work properly, right? And so many other stuff, right? So they wanted to automate this process and use the machine learning, and this is a very popular data set, guys. What I am using is a subset of data set, subset of this data, right? So basically, if you see, we have very few records. That means if you check this, I have already seen. Let's check the shape of the data set. So 25 records. Now let me check the last few records here. So you see the data is from 1952, 53, 55, 57, 58, right? And then we have 74, 75, 7, till 78. So we have 25 records for the 25 different years. And these are the features. These are the features, right? And these features are nothing but year is the year, right? It is self-explanatory. And after that, what we have here is we have the price. What is price? The price is nothing but the price of wine. So let me write it here. That what are these features are. Here is self-explanatory. Price is nothing but the price of wine. Price of wine. Then we have winter rain. Winter rain is again self-explanatory. It's a winter rainfall in millimeter. Then we have AGST. AGST is average growing season temperature. Okay. Harvest rain is harvest rain. And then we have the age, the age of wine. So how old the wine is, age of wine. And then we have the France population. France population. Population of France. So this data is from the France. And now, why these things are important? Because the quality of wine, the major ingredient in the wine is the grapes, and the quality of grapes will depend on the soil, right? Will depend on the climate, on the weather. So how much rain, what is the humidity, what is the temperature, what is the sodium, potassium, magnesium, everything, right? In the soil. Yes, Kalyani. Yes, Kalyani. The link is in your. Uh, so that is the reason I was asking you guys. So please try to respond sometime. It is not only for me. File is open. File is open. Why not CSV? I did not open it. Guys, anybody else could access the file? Yes, great. So file is not open probably. You can download it. I did not open the file. I have checked my system. Thank you guys. See, this is the benefit actually. Otherwise, what will happen, right? You do not have the file, and I'm started explaining the whole concept, and you will left behind. No, I did not open it. I did not open it, and other people are able to download the file. Guys, I hope everyone has the file now. Can you please confirm? Google Meet. Okay. Just 1 second. Guys, please join the Google Meet, right? Sudhir and Shiva. depend on the age also. Let's say we're talking about a 170 centimeter male, and if the age is 20 years or it's 45 years, do you think the weight will be same? Because we have seen that age is a factor, the weight is a factor of age also. Usually we tend to gain weight with the age. So if we do not have the information of gender and the age, can we build a better model? We can build a model, but that will not be a good model. Correct? Status, definitely, right? Your parents' BMI, because it's genetic also sometimes. In which part of the globe uh, you are from actually. So if you're from Punjab or if you're from the northeast, definitely the build is different. Again, the same thing if you're from South Asia and you're from Africa, again the build is different. So we cannot train the model at one place and we cannot deploy the model at another place. So my training and testing should be in a similar environment. My training and testing in a similar environment. So I cannot say that in the class I have explained you 17 plus 14 how to add up two numbers, and in the exam I cannot ask you the question if I haven't explained you right. I should not be asking you. I should be asking the similar question. So the data what you have used for the training, that's the similar data you should use for the testing as well. So we cannot build a model at one place and we cannot deploy at another place if there is a lot of difference. Clear, guys? So we need the sometimes we need more than one features. Most of the time we need more than one features. And if you do not have these features in the model, we cannot build a better model. I hope I'm clear, guys. Okay. So what we do? Last time we have built a model, right? Last time we have built a model, and with the model, what we did? We calculated the sum of square error. We calculated the MSE value. We calculated the MAE value. We calculated the MAP value. Everything we have calculated. Right. Now what else? Will will that work? This. Guys, Hello guys, are you there? Okay. Okay, great. So basically, what happens here, right? So, for example, in some cases, we in the classes, let's say, let's talk about the kids, and there are some students in the class. Let's say the teacher explained you 17 and 14 how to sum it up, right? So, student one, they simply remember it. They simply remember that 17 plus 14, what is the answer? They do not understand the concept. Then we have S2 kind of students. They try to understand the concept, right? And S3, they don't care. They paid the fees, but after that, they don't care, right? So now, in the unit exam, let's say that if we have the unit test, and then we have the final exam. Let's assume that your performance will be evaluated basis on the speed and the accuracy. Your performance is evaluated basis on the speed and the accuracy. So, which kind of a student? And in the unit test, it is for sure that teacher is going to ask you the same question. What example they have taken in the class, or what example they have given in the class. So, which kind of students will perform best here? Which kind of student will perform best here? S1, S2, or S3? Guys, who will perform best in this case? S1, S2, or S3? Performance is evaluated on the basis of accuracy and speed both. So S2 has to calculate, right? 17 plus 14. But S1 know the answer. They remember it. They have photogenic memory. So they know that 17 plus 14 is how much. So according to me, S1 will perform better. What do you think, guys? Hello, Bhavesh? Yes. So do you guys agree that why S1 will perform better here? Yeah. Because in the unit test, it is for sure that they are going to ask you the same question. And now because I remember it, right? So I need not to calculate. I know the answer and I can give the answer as S1. Then S2 and then S3. S3 anyway, they don't care. Now, in the final exam, we are not going to ask. So here we are asking the same question. Same question in the unit test. In a unit test. But in the final exam, it's not the same question. Here it's the same question, and here we will get the similar question. Now, who will perform better here? In this case, S2, because S2 knows the calculation. Then S1, then S3, right? Because S1 and S3 both are in the same category now, right? Because S3 do not care and S1 did not understand. So they may not be able to answer the question, right? So what is happening here? S1 is trying to overlearn. S1 is trying to overlearn. S1 is trying to remember the points, remember the dots, remember the concept, the numbers, right? But not so. Who will perform better in the final exam? Who can generalize, right? If I remember, if I only remember, then probably I can answer only this question. But if I understand the concept, you ask me the different question which is similar to this, I should be able to answer you, right? So what we are looking for from the machine learning model is that machine learning model should generalize, right? It should not be very specific to the data points what you have given. So basically, we are looking for a simple model. We are looking for a simple model which generalize. So what we are looking for? We are looking for simple ML model, machine learning model, which generalize. Clear? Now, what happens? Let's say, for example, I have a data set. So first thing, what I'll do, I will choose my X and Y. I will choose my X and Y. X and Y. So this is my data set. Y will be always 1. X can be 1 or multiple. X can be 1 or multiple. X is my IDV, which is independent features. Y is my dependent feature, which is target variable, or we call it the response variable. And after that, we split the data into train and test. We split the data into train and test. See, pre-processing, choose X, Y, split the data in train and test. Now let's split the data into train and test. So let's say this is my train data, this is my test data. Train and test. And usually this will be into 70-30 ratio, 70-30%. That means 70% goes into train and 30% goes in test, or 80-20%. That means 80% goes in train and rest and remaining 20% will go on in the test set. So we divide the data into train and test. We feed this model, we feed the train set for training the model, for training. And after that, we do the prediction, we evaluate the model. The same thing we perform here as well, and we do our job. Okay. Once again. So I have my data here. I am going to divide my data into two parts, which is nothing but my train and test. Now, this is my train. This is my test. So this data I will feed into the model, ML model. Let's say in this case linear regression. And what I'm expecting here, I'm expecting the beta and C, or a straight line here in this case. I have got the equation from the train data. Right. Now the same equation I'll be using for the prediction. So we will do the prediction on train data, and then we can evaluate. Evaluation means you need to calculate your SSC, MSC, RMSC, MAE, MAP value. Clear? Now, using the same equation, we will do the prediction. On test. So this is basically, we are doing the prediction on the same data, and here we are doing the prediction on a similar data. So this is what This will be same data and this will be similar data, right? So here it's like a unit test and this is like your final exam. So I cannot judge a student's only basis on the unit test performance. I need to check the final exam marks as well, right? So we train the data only once. We teach the concept in the class, let's say once, twice, right? Once it is freeze, right? It has been agreed between the teacher and the learners that the concept has been clear. So there will be unit exam where they will get the same question. They need to answer it and they will be evaluated. So giving the answer is just like your prediction. Evaluation is just like calculating your MAE value, RMSE value, and so on. Similarly, in the final exam, your learning has been already freezed. You are already been learned, right? Now you will get a similar question. Now from that similar question, you need to answer, and answer is again nothing but the prediction, and then the evaluation will follow. So this is what the life cycle will look like. Definitely, you may not be satisfied in the first go. So what happens? So if you're not satisfied in the first go, then this process will repeat multiple times, multiple times, sometimes 5 times, sometimes 50 times, right? Many people call it as a hit and trial, but we call it as a iterative method, because there is no way. I'm not talking about me and I'm talking about you. I'm talking about any data scientist that they know before building the model that which model or which parameter will work best. So we'll have to try the different models, the different parameters, right? And we have to make a note of it, and then we need to compare and we need to finalize one model. Am I clear, guys? One by one, Raju. One by one, we will see if I'm using a term. I am expecting this kind of questions, right? So we will explain you. Definitely, I'm going to explain you. So let me know if you have question till here. That part definitely will be explained. Any question here, guys? Any question so far with the flow? So in the EDA, let's say for example, you find out the missing values, that there are some null values, some missing values. In the pre-processing, you will fix it, right? I will explain you missing values concept tomorrow. Okay. So there is a basic difference in the EDA and the pre-processing. EDA is basically the data analyst job stops at EDA, while the machine learning consultant, machine learning engineer, data scientist, their job includes start from the data, understanding EDA, pre-processing, and do everything. Okay, guys. I hope the flow is clear. Okay. Any question from anyone, guys? Any question from anyone here? Yes, please. Pandas. Okay. So let's assume that I have already performed the EDA and the pre-processing. Let's assume that. Okay. We will see that what is there. So we need to perform EDA, which you will definitely do it. And the pre-processing part, I will explain you. Few things I've already explained, few things I will be explaining. Pre-processing, let's say this is also done. Then choose my X and Y. So I already have my X and I have my Y. So let's assume that I am going to build the model to predict the price of wine based on the AGST. AGST is nothing but one of the independent feature, right? One of the independent feature. Now, what next? The next is that I need to split my data into train and test. Split my data into train and test. So let's say here I have 25 records. I have records. So not all the 25 records I am going to use for the training purpose, right? I will keep some record, right? Or let's take analogy that I have 20 examples, right, in my book. I will not explain all the 20 examples in the class. I'll explain, let's say, the 15 example, right? And rest five examples I will ask in the final exam. You getting my point, guys? Let's say that I have total 20 examples in my notebook, right? I will not explain you all the 20 examples in my class, right? I'll explain, let's say, 15 examples in the class and ask those questions in the unit test, and rest 15 questions I may ask in the final exam. Okay, so my train and test, they are mutually exclusive. When I say the mutually exclusive, that means that 80% data or 70% data will go in train, and remaining 30 or 20% data will go in the test. And how to do it? Right, guys? Yes or no? So for this, we will use the sklearn package. Sklearn, right? We basically use for the machine learning. So the way I explain you that what are the packages, right? Pandas and the NumPys, Matplotlib and Seaborn we have learned in the Python classes, right? So here we will be using the sklearn for splitting the data, and sklearn will be used for most of your machine learning work. So basically what I want to do here is I want to split my data into train and test. Data split in train and test. In train and test. So we will use the package called sklearn dot model selection, import train test split. So basically what it will do, it will give me the 4 output. Before that, the same thing what I have imported here is I am going to use, and the input will be here my uppercase X, right, and lowercase y, what we have already got it from here, X and Y. Choose X and Y. So these two things I'm going to input here, and then I will specify that what is my train size. What is my train size? So let's assume that train size is 80%. So for 80%, we will use 0.8. 0.8. Okay. And now this will give me the 4 output. This will give me the 4 output. One is X train, X test, Y train, and the Y test. Right. Now, but this has a problem. This has a problem. Now, what is the problem? I'll explain you. So basically what you got here is, because you have X, you have Y, right? And then you are dividing the data into train and test. So basically what you will get is kind of this. If you divide your data into X and Y, you already have your X and Y, and you know that you are going to divide the data into train and test. So this is train and this is test. So basically what you will get something like this. 4 things. And this thing, guys, is common across all the algorithms. So that's why please focus here, because if you do not understand here, it will be difficult to catch up, right, in the classes. So now, so this is my x, this is my y, this is my train, this is my test. So basically, this block will be x train, right? X train. This will be my y train. This will be my x test. This will be my y test. Did I get the 4 different blocks? Did I get the 4 different blocks? X train, y train, x test, and y test. So now this block, train block, will be used for training the model. This will be used for training the model. Right. So here also I have got the 4 things: x train, x test, y train, and the y test. Now let's check the shape of it. Let's check the shape of it. So guys, before I try to print that what is x train, what is x test, right? What is the shape of it? Can you please tell me that what is the shape? Print shape of x train is, guys, what would be the shape of x train? So train data, we will have 80%. 80% of 25 records is 20 records. In X, we have only one feature, AGST. So it's a 20 by 1. I hope this part is clear. Similarly, you need to check the shape of Y train, shape of X test, and Y test, everything. So X train, Y train, the shape will be 2020. X test, Y test, that's the shape will be, I'm talking about the number of records, because the ratio is 80% and 20%. So 20% records went to the train data, and 80% records went to train data, and 20% records went to the test data. And because in the X we have only one feature, X is only one feature, that is the reason I have only one column, and Y is one feature, that's why we have 5 1. This part is clear, guys? Any question on this? Guys, I hope I'm audible. But you can simply say yes, no on the chat box also, so that is fine, right? So because I don't want to be really fast, and I don't want to be really slow. Okay. Any question, guys, here? Any confusion? Because this will be common for your 60% of the course, 60 to 70% of the course. In every class, we are going to use the same thing. Mm-hmm. Yes. Okay. Great. Now the problem here is because it is randomly taking the 80% record, randomly 80% record. Now, because it's taking the random 80% record, every time it will give you the different output. Every time it will give you the different output. Why? And how to check it? Let's say the X test. Let's check the X test. I know it's only 5 records. That's why I'm printing everything. Otherwise, if it's a 5 million records, I cannot print on the screen. So the record number 5, 7, 17, 24, and 3 came in the X test. So just for your understanding, one time I'm explaining you, X train will be everything but these 5 records. So in the X train, you will not have the 5th record, you will not have the 7th record, 17th, 24th, and 3rd record. You will have rest other remaining records. Clear? Because it's a mutually exclusive. Train and test are mutually exclusive. So the data what is in the train cannot be in the test. The data which is in the test cannot be in the train. Now, the problem here is that every time, let's see that every time I run this, I will get a different records. So X10, this time 15, 12, 2, 13, 22. If I run one more time, this time 17, 16, 11, 24, 9. So every time I run it, right, I will get a different number of records in the test data. So which indicates that the different number of the different records, it will be similar, but it will be different for the X train also. Right. Now, because if the records are different, my equation will be different, my answer will be different, right? The problem here is that I cannot reproduce my results. I will not be able to reproduce my results. So to fix this problem, we use the random state. Random state. So now random state, we put any number, right? Number can be 0, can be 1, can be 5, can be 10, right? 1000, anything. But there should be number. So if you're using a different number, your results will be different from my result, right? But, and I cannot say that your result is wrong or my result is wrong. Both results are correct. The intention here is that we should be able to reproduce our results. So now, every time I run now see 5, 21, 22, 18, 15, every time I run this, I will get the same numbers. This is not going to change. This is not going to change. 5, 21, 22, 18, 15. This is not changing. So the random state, the purpose of random state is to fix the seed. To fix the seed, that means to reproduce the results. So the purpose of random state is to reproduce the results. Yes, Rajiv, please. Hmm. No, we always need to do randomly. We always need to do randomly because yeah, definitely, right. How to select the number of rows and number of columns in the pandas, right? So we can do that, but that is not the right way. The right way is we always do it randomly. Okay, because before running the results, how will you know that I need to test only on these 5 records? No, some 5 random records, and you will have to appear in the exam and need to give the right answer for those questions. Okay, so random state is only to reproduce the results. Any number is fine. Any number is fine, right? But there should be some number. Clear? So now, because I have already fixed it, so let's say we got X test and we will get the X10 also. Now the X10 will be mutually exclusive of it, right? Because it has the 20 records on the screen. I am not going to keep it. I'm going to just remove it, right? So we have the X test, we have the X train, we have the Y train, we have the Y test. What next? So data EDA part has already been explained in the Python classes. Pre-processing, I will explain you. Choose X and Y, done. Split the data into train and test, done. So for any question, guys. Now comes the model training. It is quite easy. Model training, right? So we will use again the sklearn dot linear model, import linear regression. Now The linear regression is the function what we are going to use, right? Now here I'll copy this and I will create an object and we'll give a name here. The name I'm giving LR, you can give any other name, right? It's a user-defined name. You can give the linear model, you can write the price model, you can write the wine price model, whatever. So it's a user-defined name, guys. It is a user-defined name. Okay. So, and this object we will be using further. Now, as I said that only training data will be used in training the model. Only training data. So what are the training data, guys? Training data is X train and the Y train. Agree? Training data is nothing but your X train and the Y train. X train and the Y train is your training data. Because I do not want the model to see the test data. Model is not aware that what is there in the test. So it will be surprise test. Okay. So here, let's use LR. You can use LM. See, again, this is a user defined name, guys. It's a user defined name. So you can change it. Now, this model object LR, which is I am using LR dot fit. Now here I will have to feed the data of train. So train data is nothing but X train and the Y train. X train and the Y train is my train data, right? So this step is for model training. This step is for model training. Done. So whatever we have made in Excel file, right? This is done here itself. In the 3 lines code, it is done. Whatever is the calculation and all everything what you learn, that is for your understanding, right? In the real life, you're not going to use it anytime, right? You are going to use the syntax. Okay, because for 1, 2, 3, 10 records, you can predict, you can calculate, but not for all, not for the bigger data set. So that is the reason we are going to use the packages. And in the packages, you will be using the algorithm. Clear, guys? So we have already built our first model, which is a linear model. Linear regression model is done. Now, to get the coefficient, so this is my coefficient and this is my intercept. LR dot coefficient, LR dot intercept. Now, actually, basically, so coefficient is nothing but your beta. So coefficient is nothing but your beta. So your, let me call as a beta. Beta is equal to what? 0.74. This is the beta value. This is the C value. This is negative 5, negative 5.1. Okay. Now what is the equation, guys? Equation, if you remember, y is equal to beta x plus c. What is y here? In this case, y is price. Beta is equal to 0.74. 0.74. Let me round it off. What is x? X is nothing but AGST. What is c? C is minus 0.5. 13. Did you get the equation, guys? Did we get the equation? Yes or no? Any confusion here? Any question? There's any question, any confusion? No question. Right. So we already have the equation. Now, can I do the prediction? Can I do the prediction? So prediction will be on train data first. Prediction will be on train data first. First, we will go for a unit exam. Right. So we already have the beta and C. Now what we are going to do is we are going to do the prediction. So prediction is nothing but you give me the X value or AGST value, I'll give you the price. You give me the AGST value and I will give you the price. As simple as that. Fair deal. Right? You tell me the AGST value and with the equation, I'll feed it out and I'll give you the price. Now, but because we are using the Python, we are not going to do any manual calculation. So we will simply use a function called prediction on train data, on train data. So this will be, let's say, prediction underscore train. So again, a user defined name. So my model name is lr dot predict, and I will be giving the x train value. X train. What is x train? In this case, let's assume that, or let me write here just for understanding, that this is AGST, this is price. Right. So for a given AGST, I am expecting the price. Correct. So what is AGST? AGST is in which block or which data frame? X train. So for the prediction, we will be using the X train, guys. So this is very important, and this is the only thing which is right, which you need some attention to understand this part, because this is common for all the algorithm, guys. So model object dot predict, I am giving X train. So you need to understand why X train. Why X train is because AGST is in X train, right? And based on AGST, I am going to write the price. Or for your understanding, let's say this is the height, this is the weight. So for a given height, you are going to calculate the weight. So in Excel file also, if you remember the form, in the formula, we use the height, not the weight part. Okay. So we have already got the prediction. Now, guys, can you tell me that how many predictions we will have here? How many predictions? Yes, exactly 20. Why 20, guys? Why 20? The 20 records for the train records. Right. And I am doing the prediction on train data. So I have 20 records for AGST, and for those 20 records, I am looking for 20 prices. So I have got 20 records, 20 predictions without calculation. But if you want to find it out, you already have your X train, you can feed it and you can check. It will be exactly same. It will be exactly same. But we are not going to do any manual calculation. We are going to use packages here. Clear, guys? So we got the prediction on train data. We have got a prediction on train data. All good? Yes, no, maybe. Okay. Now, what next? The next is, you can toggle from here as well. So we have already done the prediction. Now the next is evaluation. In the evaluation, what we will use? We will use the SSC, MSC, RMSC, and other things, right? So for this also we have a package. Model evaluation on train data, right? So here we will use from sklearn import metrics. Import metrics. Right. Now let's do the train evaluation. In this, we have the actual value. If you remember, guys, in the Excel file also we did the same thing. Actual value, and we had the prediction value. So can someone please help me to write here what is the actual value and what is prediction value? What is actual value? what is actual value, guys? Yes. So if I need to find out, let's say in case of X train, Y train, X test, Y test, this is my actual value. You remember that? This is my X, this is my Y. Because we are looking for train data, so actual value will be Y train. This part is important, guys. You cannot remember this. You need to understand this part. Y train is my actual. Y train is my actual. And then what is prediction? I have just calculated prediction train. This is not the actual code. This is just for our reference. Any question on this, guys? This is important. I can spend some time here because this concept has to be used in most of the algorithm, in all the supervised algorithm, in all the algorithm in the supervised space, everywhere. Let's say this is your data, right? Yes, yeah, from this sheet, right? But in the Python example, I have taken a different example here. So basically, what it is there, let's say this is my X, this is my Y. This part is clear. What is behaving weirdly? Just one second. Just one second, guys. And let's say that I divided the data into train and test. So this is my train. This is my test. This is train. This is test. So this part is my X train. This is my Y train. This part is clear. Right. So now, if I need to do the prediction, so this is my Y is my actual value because it's actual weight. And when I do the prediction, I use some formula and we do the prediction here. Correct. We do the prediction. So what is actual value? Actual value is basically your Y value. Because here you have the actual weight, you have the actual price. So actual value is Y value, that is for sure. Now because we are concerned about my training set, so this will be Y train. So in one column I have the Y train value, in another column I have the prediction train value, and then we calculate the error. And in the error, what is error? Basically, error is nothing but your actual minus prediction. Error is nothing but your actual minus prediction, right? So in the error, we take two things. Error is equal to actual minus prediction. This is how we calculated in the sheet. Or I can say the actual is a function of Error is a function of actual and the prediction. Error, error is a function of actual and the prediction value. So similarly, I am going to use this actual and the prediction value for my function. With the function, I am going to calculate this, right? So let's assume that, guys, anybody else is having any issue here? This is very important concept. This is very important concept. Let me know, please. Let's calculate the MSE value. MSE is nothing but mean squared error. Mean squared error, because we have the direct function for this. For SSC, we do not have the direct function. So this we will use matrix dot mean squared error. Matrix dot mean squared error. And here we will write actual value and the prediction value. So actual value is my Y train and prediction value is prediction train. Prediction train. What I have written in the start. Correct. So I already have my MSE value. So let me write here is the print train. For train, actually I am calculating the mean squared error. Mean squared error, which is nothing but MSE value. So this is nothing but my MSE underscore train. See, you have got the answer. 0.222136462782528. So basically, in the reality, in your real life execution, you are never going to calculate anything. You're not going to use any mathematical formula. But it is essential that you must know it. So we know that how to calculate the mean squared error, guys. Yes or no? What do you think? Yes, definitely. So yeah. If it is zero, that is ideal. That is ideal, right? So we are looking for lower error, right? We are looking for lower error, correct, Raja? Yes. Now, similarly, we can find out the RMSE value also. What is RMSE? Is root mean squared error, RMSE train, right? So this part we can use matrix dot root mean square error. Already have a function root mean square error, root mean square error, right? We need to again provide what is actual value is Y train and what is prediction value is prediction train. Prediction train. Now print train. We're looking for root mean square error, root mean square error, which is nothing but RMSE. RMSE. Guys, one thing, right? See, my job is to come here, right, and speak for the 2.5 or 3 hours, right? But if you guys understand it, yeah, it will give me the motivation, right, to tell you a few more concepts to go further deeper. But if you're not speaking anything, if there is no interaction, probably I will also lose my interest, and that time definitely I will not suffer. Okay. So the sincere request, it is not only for me, it is for you that you be attentive in the class and ask questions. Right. So we have got a root mean square error also. Correct. Similarly, I can go for MAE value. MAE is mean absolute error. So we have the direct function, guys. We have the direct function for everything. Matrix dot mean absolute error, Y train, which is my actual value, prediction train, which is my prediction value, and then the print. So we have got the MAE value also. What is MAE value? MAE value is 0.38. So 0.38 indicates that, as you know, that I cannot interpret MSC and RMSC, but definitely I can interpret the MAE value. So MAE value is telling me that there is a deviation of 0.38. That is absolute deviation. So the price range is on an average, right? There is a error of 0.38. If it's in dollar, it's a euro, it's a euro, right? Similarly, I can find out the, yes, please. Mhm. Raja, did you attend the first class, first session? So, yes, so please join in the time, right? So this has been explained, and what you're saying is correct. So here we take the absolute error for each row, and then we take the average of it. Okay, you're welcome. So we already have the MAPE value. MAPE value is 0.54, which is nothing but 5.4%. Or I can say that there is a deviation of, on an average, 5.4% deviation, which is quite good. Which is quite good. Okay. Now, because we have these many number of digits, right? I do not like it, right? So let's do one thing. Let me use the round operation. I only want, let's say, two digits after the decimal, so I can use it, right? So 0.22. Same thing I can do everywhere. Round. If you want three digits, you can use three. So it depends on you that you want three digits, you want two digits, right? You can use the round off operation, right? So we have got the error also, evaluation for the train, right? Now, guys, I have the MSC. I did not calculate the SSC value, but can I calculate the SSC value? There is a no direct function here. So what are the ways? How can I calculate the SSC value? If it is required, I know the formula. MSC is equal to what? SSC divided by N. So SSC will be how much? MSC multiplied by N. So in this case, what is the N value? N value is 20. So can I calculate the MSC SSC value? Right. So guys, any questions so far? So we have already discussed these things. Choose X and Y. This part we will explain tomorrow. Pre-processing part. Choose X and Y. Split the data into train and test. Train the model. Prediction on train and evaluation on train. Any question? Will be explained step by step, Raja. So probably in the next class, next to next class, right? It will take some time, but definitely I'll explain it. Okay, you're welcome. So guys, any questions so far? No question. So what next? The next is that I need to do the prediction on test data. Prediction on test data. Yeah, definitely, definitely. Because as I said, right, that you are going to do the prediction on train and prediction on test, and probably you will not be satisfied. So you need to repeat this multiple times, right? So multiple times, right? And we call it the iterative method, right? Because we are going to perform the experiment with the different features, the different models, till the time I am satisfied, right? And after that, we finally get a model which is the golden model, which we call as golden model. Mhm. Yes, right. Correct, correct. Yeah, you're welcome. Okay, so now what next? The next is I am going to do the prediction on the test data because only basis on the unit test I cannot say anything. Prediction on the test data. So if I need to do the prediction on test data, so guys, let me call it a prediction test. Now you tell me that what should I write here? What should I write here? What should I write here? See, excellent. Any other answer? So previously I did the prediction on the white train. Sorry, not white test. See, the thing is very simple actually. Let me go to the Excel file. So if you are doing the prediction here, if you are doing the prediction here, right? If you remember which variable you have taken, which cell you have taken. In the prediction formula, which variable is there? Right. So we are calculating weight based on height. So for a given height, I am looking for a weight. So here I need to provide the weight. Sorry, here I need to provide the height to get the weight, right? Yeah, just one second. Somehow this Excel file is not working. Just one second. So here, if you remember for the prediction, we have used height in the formula. Remember that? Okay. So for a given height, I'm looking for a weight. Actually, the prediction is also what is the unit of the prediction? It's weight. So prediction, I am looking for prediction and the actual is both are the weights. So in this case, in our case, right, the wine price prediction, we are looking for the price, right? So if I provide the X test, I will get the prediction test. Correct, Rajiv? If I provide the X test, I will get a prediction test. So here we will be writing the X test. So guys, these things are really important. This thing we may get confused if you do not understand this part. Again, we may perform good in the unit test, but it will be difficult for the final exam. right? So prediction test is nothing but LR dot predict. I got the X test. So now, guys, how many predictions we are expecting here? 5. Why? Why? Because we have the 5 records in the test data. We have 5 records in the test data. Okay. Now, so we already have the prediction test. Now, so this time, guys, this time if you see, right, I did not build any model. I have used the same beta, same AGST, right? Same AGST, sorry, same beta and the same C, intercept and and coefficient. Otherwise, you need to do this same formula, right? My beta and C is because I built the model and this is already freezed. So again, by using the same formula, you can do the prediction. You can even try that after the class. So for a given AGST, now let's do one thing. Let's calculate one, and after that you will understand. So what is X test? X test was 17.48. What is the formula, guys? Let's try. What was the formula? This was the formula, right? And what is the value of AGST? 17.4833. Shall I put it here? Let's say P1. $7.880. What is the value here? Why 844? Because I have rounded it off, right? Because I have rounded it off. Let me go and check exact value. What is AGST? What is intercept? Minus 5.133. So basically, functions are nothing but we know how to do the calculation. It will simply make it faster. My bad. $7.84462, right? 7.84462,304. Yeah, right. So it's the same thing. The only thing, because you are not supposed to do any manual calculation, because again there is always a chance of error for any manual thing. So that is the reason we are using the functions which is tried and tested. So first thing is, let's say for example, you have the only 5 records, you can do it, but what if you have the 5 million records? You cannot do the manual calculation. Even if you can do it, right, who will trust it, right? So that is the reason we are going to use the functions here. All good, guys? Any question? Any question? So we have done the prediction on test data. In this case, guys, can you tell me that what is the actual value and what is the prediction value for test evaluation? Actually is Y test. Very good. And prediction is excellent. Guys, I hope you are getting the point. And if you're not getting the point, please ask, because I do not have any superpower, right? So if you don't ask, I'm assuming that you are understanding it. Okay. And I do not want to bother you. Now, again, we need to repeat the same thing. MSC test is equal to matrix dot mean squared error. Y test, which is my actual value, and prediction test, which is my prediction value. So print test MSC. I have got this. Next, I need to calculate RMSE test, root matrix dot root mean squared. Why it's not coming? Root mean squared error. Again, my actual value is y test, prediction value is prediction test. Okay, root mean squared error. So we have got a root mean square error also. Same thing, I need to calculate the MAE value, MAE test. So matrix mean absolute error, again the actual value. So this is same, guys. This is same, right? I am not changing this part. This is same. See, it's all highlighted. Same thing, right? Mean absolute percentage error, actual value and the prediction value, and we have got it. So we have the train accuracy and the train error and the test error. One thing is we need to make a note that in the regression problem we never talk about the accuracy. We always talk about error. We always talk about error. So now I have two things. One is my train evaluation, second is my test evaluation. Right. So we'll have to compare it and we'll see that what does it mean. We will proceed from here in the next class, guys. Let me know if you have any question. Sorry. Mhm. Okay. So that part in the next class. We will use the gradient descent, right? Advanced algorithm, right? And that will tell me that which line is the best line. See, basically what happens, right? I'm because you asked, right? I am just giving you some hint, but the complete answer will be in the next class. So we have a straight line. Any straight line is a function of y is equal to beta x plus c. So for every a straight line, we must have the beta and c. Yes or no, Nadeem? Right? And I have said that we may have multiple lines. We may have multiple lines, and for every line, I am going to calculate. We may have the multiple lines here: L1, L2, L3, L4. Right? For every line, I am going to calculate the SSE value, sum of squared value. Where I get the least value, that line will be my best line. And if I have a line, I have a beta and I have a c. Correct? If I have a line, that means I have a beta and I have a c. Yes or no? Right. And just to answer your question, because the time is over today, right? And this concept will take some time. But let me tell you that we'll explain you in the next class. So, for example, yes, yes, right. Okay. So this will be explained to you by using the gradient descent. Okay. So, guys, any question here on? So we are still using the linear regression, and it will take, I think, one more day to complete this part, to complete this algorithm, and the concepts what I'm using, like how to split the data, right? How to do the evaluation, right? So this will be common across all the regression technique. Then we'll spend really a good amount of time for the classification, right? And again, those concepts will be common for all the algorithms. Okay. So guys, do let me know if you have any question here. So I have got the train data and test data, but what to do with this? What to do with this? This part, let's explain, let's understand in the next class. Yes, definitely. Yes. So what does it mean is, from the basic perspective, right? Uh, you can say that in the unit test, the performance was 0.388. I think I have copied the same thing. Just one second. Yes, just one second. But in the final exam, it got different. But even how to interpret that part, that will take some time, and we'll explain you tomorrow. I hope that is fine. So we have train and we have test. So basically, we have the unit test marks and the final exam marks. So this is my train data, kind of a unit test. This is final exam. So here you are making 5.5% of error, let's say percentage of error on an average. Here you are making 6.6% of error on an average, right? In the absolute term, here you are making the average mistake of 3.388 in the price. Here you are making 0.45 in the price. So your final exam, right, performance is not so bad as compared to the unit exam. So I can say that model is generalized. Again, I do not want to use the different jargons because we are towards the end of the class and you may go with the confusions. So this part we will explain in the next session. Clear, guys? Any question on this? Mhm. Yes, tomorrow we will use. Yeah. Yes. Which chart? Yes. Yes, yes. Hmm. Yeah, you're welcome. So, guys, any question on this, guys? Any question? So, first thing, is the flow clear? See, what is important here is that you need to understand the flow. Second thing is that you need to understand that what goes in the training, what goes in the prediction, right? So, if I use lr.fit, what I should be writing there? It should be x train, y train, the training data. If I'm going for the prediction on train data, so I'll be writing x train. If I'm going for the prediction on test data, I'll be writing x test and y that, right? So that is important. Okay, guys, any question on this? Yes, the sequence is. Yes, Kalyani. Yes, yeah, from tomorrow. Yes. From tomorrow, yes. Okay. From tomorrow, yes. Okay, I got the point, Kalyani. From tomorrow, we'll Google Meet. Mm-hmm. I got the point, Kalyani. Yes, we will be using the Google Meet from tomorrow, right? So here also you can ask me question. What there is no issue, but yes. Okay, Kalyan. Got your point. Yeah, thank you for suggestion. We will be using the Google Meet. I have already informed in the class that from tomorrow onwards we will be using the Google Meet. Yeah, you're welcome. So guys, any other question on this? Very nice, thank you. Hmm. Thank you guys. Let's meet tomorrow. Take care, guys. Thank you, guys.